Hi guys. Hey, I'm going to work through practice problem number 1 and number 2 for you so that you're better prepared to do number 3 for this in this week's assignment. So I'll do 1 and I'll do 2, and then number 3 you guys can complete on your own. I'm making this video because I've gotten 5 emails today from students asking for help. And I understand this is our introduction to stoichiometry, and stoichiometry is the most difficult and involved unit of the year. I'd say stoichiometry, and then chemical reactions, I'd say would be the second, in my opinion, would be the second most difficult unit of the year. So stoichiometry, in stoichiometry, we use these. These hopefully look familiar. These are from, one of these is from unit number 9. Remember, this is the molar conversion triangle of science. So we used one of these in unit 9 to convert grams of a chemical to liters of the same chemical or number of particles of that chemical. But in unit 9, we only used one triangle when talking about one chemical in a reaction. For example, we might use the triangle if we were converting just zinc or just silver 1 nitrate or just silver or just zinc 2 nitrate. But now in stoichiometry, what we want to do is we want to be able to compare 2 different chemicals in a balanced reaction. So these 2 chemicals, or these 2, or these 2, or these 2, or these 2, or these 2. We can compare using stoichiometry any 2 chemicals in a reaction. And this is our introduction to stoichiometry. This week, I'll give you a little explanation of this week and next week. So in this week, the problems this week, we are converting moles of one chemical, which we'll call chemical A, to moles of another chemical, in this case chemical B. That's all we're doing. We're giving you the moles of one chemical and asking you to figure out how many moles of the other chemical are needed. That's it. Next week, we're going to give you grams of a chemical and ask you to figure out how many grams of another chemical are needed or are made. If you start with this many grams of chemical A, how many grams of chemical B do you make? And to do that, you're going to multiply by 3 conversion ratios. You're going to multiply by this conversion ratio to change chemical A from grams to moles, multiply by this conversion ratio to change moles of chemical A to moles of chemical B, then multiply by this conversion ratio to change moles of chemical B to grams of chemical B. So that's next week. This week, we're just changing moles of chemical A to moles of chemical B. That's it. So let's jump into it. This week's assignment has these 3 practices. In practice number 1, I'm just going to double check here, make sure everything's in field of focus. Okay, so practice number 1, we have this balanced equation. We have 1 mole of zinc solid reacting with 2 moles of silver 1 nitrate solution, aqueous solution, and that's going to yield 2 moles of solid silver and 1 mole of zinc 2 nitrate solution. So remember, the coefficients, the big numbers in front, tell us the number of moles. And that's what part A is asking us to do. It says for every blank moles of solid zinc is right here, and there's only 1 mole of solid zinc here. So for every 1 mole of solid zinc used, blank moles of solid silver are produced. Well, here's your solid silver, and that's 2. So if you use 1 mole of solid zinc, you make 2 moles of solid silver. And every multiple of that's true. What if we use 2 moles of solid zinc? Then we'd make 4 moles of solid silver. So this 1 to 2 ratio is the same as 2 to 4 or 3 to 6. These are all the same ratios. Now in chemistry, we don't write ratios with the colon in between. The way we would write that, and let's just do that. Let's just jump down here to write 3 mole to mole conversion ratios. So we would write that like this: 1 mole of zinc is equal to 2 moles of silver. See, this is how we'd write a ratio in chemistry, a conversion ratio. We're saying 1 mole of zinc is equal to 2 moles of silver. Now, you could also write it this way. 2 moles of silver are equal to 1 mole of zinc. So both of these, it's the same thing. The one you use depends on, if we look back at our molar conversion triangles of science, which one do you use? Do you use 1 mole of zinc on top, or do you use 2 moles of silver on top? The one you use depends on which way you're going. If you're going from chemical A to chemical B, you would put chemical B on top and chemical A on bottom. If you're going the other way, chemical B to chemical A, then you would put chemical A on top and B on bottom. So which chemical you put on top, it just depends on which one you're trying to cancel out, right? Because in this case, chemical A is on bottom because you're trying to cancel out moles of chemical A. And in this case, right here, chemical B is on bottom because you're trying to cancel out moles of chemical B. So the next one, letter A, number 2 here. For every blank moles of zinc nitrate, that's 1. For every 1 mole of zinc nitrate, blank moles of silver nitrate are used. Silver nitrate, 2 moles of silver nitrate are used. And we could write that over here as 1 mole of zinc nitrate, I missed my parenthesis there. And on the bottom, we would write 2 moles of silver nitrate, like that. Next one, A3, for every blank moles of solid silver produced. Solid silver produced, 2 moles. Blank moles of silver nitrate are used. Silver nitrate, 2 moles are used. And here to produce 4 moles of solid silver, solid silver, blank moles of solid zinc. Well, that's actually, we got ahead of ourselves in number 1 here. If 1 mole of zinc yields 2 moles of silver, then 2 moles of zinc would yield 4 moles. That's right here. 2 moles of zinc would yield 4 moles of solid silver. So, bam. Now this down here, I know there was some confusion in the emails I received asking about what is this X mole, Y, Z mole, Q. That's what I used in my examples. Was I just said X moles of chemical A, and instead of using Q, I use chemical B. So that's all. Remember, the conversion ratio is comparing chemical A to chemical B. Whichever 2 chemicals you're calling A and B, we're just comparing 2 chemicals in a balanced reaction, and you write how many moles of chemical A over how many moles of chemical B. And we know that the conversion ratios, you can flip them upside down if you need that. So that's practice number 1. I'm gonna stop the video here so I can make a practice number 2 video. Be right back.